In this video, we're going to finish the handout that was given out in class that you can see here. Find an equation for each graph. We did 3 of these together. Y equals 5 sine a half x, y equals 0.3 cosine 20x, and we did y equals negative 4 sine pi over 8 x plus 2, and we got one more. So let's work on this last example. And to get started, we got to think about whether we want to use a sine or a cosine function, and how do we decide whether to use sine or cosine? If we look back at the earlier examples, the first one we used sine because the fundamental period that we were looking at started on the midline, right? Started on the midline, went up, down, up. So that's the kind of the standard period for a sine function. In the second example, the fundamental period that we looked at started at a max point and started the max, went to 0, negative 0, positive. So that's our indication that we should use cosine. Now, in the third example, it's similar to the first in the sense that we use sine. We started on the midline, but notice we went down. We started by going down, and so that was our indication to use a negative value for a. So in this fourth example, we're not starting at a max point, but the fundamental period that we see here is starting at a min point. So for number 4, because we're starting at a min, if we're starting at a max or a min, we're going to use the cosine function. We are not starting on the midline, which is the situation where we would use sine. So we're going to use cosine for this. And so let's take a look at this graph. We want to think about what the amplitude is. And to see the amplitude now, it's not the total height of the graph, it's the height of the graph above the midline. We have to identify the midline here, which cuts through the graph just like so. There's the midline of our wave. And we can think of the amplitude as the distance from the midline to the max or top of the wave. It's also the distance from the midline to the min, or the bottom of the wave. So it's half of the total height. So the amplitude here, I think you can probably just see it, but we can always get it by taking the max value minus the midline value, which is 5. The amplitude of this wave is 5. And but since our fundamental period that we're looking at starts at a midpoint, we're going to use an a value that's equal to negative 5, right? Because our graph is going to be based on y equals minus cosine x, not just y equals cosine x. So we have our a value decided here. Now let's think about what the period is for this graph. And you got to be a little bit careful here. The period is not 5 pi over 6. The period is the length from here to here. So there's one period. And because we have a phase shift here, we have a shift going on, our period's not starting at 0, it's starting at pi over 6. So to figure out this distance from pi over 6 to 5 pi over 6, we actually have to subtract 5 pi over 6 minus pi over 6 to get that distance from here to here. And that's going to be 4 pi over 6 which reduces to 2 pi over 3. So there's the period for this wave. One period is actually 2 pi over 3, and it's a little bit easier. If it's easier for you to think of it as 4 pi over 6, that's just fine. And okay, now we want to use my formula. Period is equal to 2 pi over b. We need to find out the value of b. And so the period, 2 pi over 3, is equal to 2 pi over b. And you got to solve for b. And you can almost just see it. If you go through the algebra, you'll see that 3 is equal to b. That is the b value. All right, so we have a constant, we have a b constant. We need to figure out c and d. To think about c, we need to consider the phase shift, and there's actually, we can see the phase shift pretty clearly here. We're starting our fundamental period pi over 6, so we have to shift pi over 6 to the right. Okay, so the phase shift on this example is going to be pi over 6 to the right. And we got two ways we can calculate it. So one way to get c is to use the double set of parentheses inside the parentheses for the cosine function. So in other words, I can write b times x minus pi over 6, the phase shift. My b value is 3, so that's 3 times x minus pi over 6. And if I distribute 3x minus 3 pi over 6 is 3x minus, that will actually reduce to pi over 2, that fraction, 3 pi over 6. So I see my c value is pi over 2. I'm not going to worry so much about whether you say c is positive or negative, as long as you realize there's going to be a minus sign in our function, because we're shifting to the right, right? We're shifting in a positive direction, so we have a minus sign in the expression for the function. The other way to get c get c, I'm trying to write get c, is to use the formula phase shift equals c over b. So here pi over 6 is equal to c, so I'm plugging in pi over 6 for the phase shift, I have to identify that first, is equal to c, which we're trying to find, over b, which is the value 3 that we've already found. So I could solve for c. In this formula, if I multiply both sides by 3, I get 3 pi over 6 is c, and that reduces to pi over 2 is c. Same value, okay? So I kind of like using the parentheses way, but if you prefer the formula c over b, that also works as well, where we're replacing the words phase shift with pi over 6 because we see that from the graph. We're working backwards to get our c value. So we got A, B, C. We still need D, and to get D, we need to think about the vertical shift. Right. And going back to my graph, we can see the vertical shift here. Now it actually is easy to make an error because it looks like the graph is sitting right on the x-axis. But the vertical shift is a measure of where the midline has moved to. The midline starts out on the x-axis, but here it's shifted upward 5 units. So the vertical shift is plus 5 on that graph. That means D is equal to plus 5 because we've shifted upward by 5. So we can just read off our D value. D is positive. The graph is shifted upward because otherwise that midline would be, if it hadn't shifted vertically, the midline should be right on the x-axis and part of the graph should be below. So I got values for A, B, C, and D. Let's go ahead and plug in to y equals A. We're using cosine bx minus c plus d. And so y is equal to, A was minus 5. Cosine b is 3x. If you're at all confused about whether to use a plus or minus sign here, just remember at this point in our final version of the answer, we want a minus sign if we shifted to the right, if the phase shift was to the right. We want a plus sign if the phase shift was to the left in the negative direction. So here we want a minus sign. Minus c is minus pi over 2. Plus d is plus 5. And there we got our result for the last one.